Right now, the artificial intelligence you use lives somewhere far away from you. It sits in a building you will never visit. Every question you type leaves your keyboard, travels hundreds of miles through cable, gets processed by machines owned by someone else, and returns as an answer that feels instant. That is what most people think AI is. But the real answer is far stranger. That entire thing can fit on the computer in front of you. Not a smaller copy, not a demo, the actual model running on your actual hardware answering your actual questions. And it keeps working when your internet does not. This is what people mean when they say local AI, a large language model that lives on your own machine, on your own drive, under your own control. No account, no subscription, no server. Does that sound impossible? 3 years ago, it mostly was. Then in early 2023, Meta released the weights for a model family called Llama. Weights are the model itself, the raw file, the thing that does the thinking. Within weeks, a developer named Georgy Jurganov wrote a piece of software called llama.cpp that made those weights run on ordinary consumer hardware. Laptops, desktops, machines with no special equipment at all. Everything you are about to understand grew out of that moment. So start with the strangest part. A large language model is a file. That is all it is. Not a program, not a service. A single enormous file full of numbers and a small piece of software that reads those numbers and does math with them. The numbers are called parameters. You have probably seen them in a model name. Llama 3.18b Mistral 7b QN 2.514 b Gemma 227b. That letter B means billion, and it counts the parameters inside the file. So what is a parameter? Think of it as a single dial. During training, the model reads an unimaginable amount of text and slowly adjusts billions of these dials until the settings produce language that makes sense. Nobody chooses the settings by hand. Nobody knows what most of them do. When training ends, the dials freeze, and those frozen positions are the model's entire knowledge, style, and reasoning ability. 8 billion parameters means 8 billion frozen dials. And every one of them has to be stored. This is where model file size comes from, and it is simpler than it looks. Each parameter is a number, and each number needs space on your drive. At the precision models are originally trained in, each parameter takes about 2 bytes. 2 bytes times 8 billion is roughly 16 gigabytes. That is a large file for a fairly small model. A 70B model at that precision is around 140 gigabytes. Most people cannot store that, let alone run it. So how does anyone run these at home? Here is where a word you will see constantly starts to matter: quantization. Quantization means rounding the numbers down to make them smaller. Instead of storing each parameter with 16 bits of precision, you store it with 8, or 5, or 4. Think of a carpenter measuring wood. One measures to the nearest tenth of a millimeter. Another measures to the nearest quarter inch. The second carpenter works faster, carries lighter tools, and for almost every job the furniture still comes out fine. Quantization is that second carpenter. When you browse models, you will see labels like Q8, Q5km, and Q4km. The number is roughly how many bits each parameter gets. Q4 is the most common choice for home use, and it shrinks that 16 gigabyte model down to somewhere near 5. Does it hurt the model? A little. Q8 is nearly indistinguishable from the original. Q4 is where most people land because the quality loss is small and the size saving is enormous. Below Q4, models start making noticeably more mistakes, repeating themselves and losing track of instructions. There is a practical rule you can carry with you. A quantized model at Q4 takes up roughly half to 2/3 of a gigabyte for every billion parameters. A 7B model lands around 4 gigabytes, an 8B around 5, a 14B around 8 or 9, a 32B around 19, a a 70B around 40. Write that down because you are about to use it. Now for the question everyone actually wants answered. Will it run on your computer? To answer that, you need to know where the model has to sit while it is working. A model cannot think from your hard drive. To generate anything, the entire file has to be loaded into memory, and there are two kinds of memory that matter. The first is RAM. That is your system memory, the general-purpose memory your computer uses for everything. 16 gigabytes is common. 32 is generous. The second is VRAM. That is video memory, the dedicated memory soldered onto your graphics card. An NVIDIA RTX 4060 has 8 gigabytes. A 4070 Ti Super has 16. A 4090 has 24. VRAM is the good one. Why? Because your GPU is built to do thousands of small math operations at the same time, and running a language model is thousands of small math operations happening at the same time. Your CPU can do the same work, but it does it in far fewer lanes. A model running entirely on your GPU might produce 40 words per second. The same model running on your CPU might produce 3. Apple users have a quiet advantage here. Macs with M-series chips use unified memory, meaning the CPU and GPU share one fast pool. A MacBook with 32 gigabytes of unified memory can run models that would need an expensive dedicated graphics card on a Windows machine. So here is how you estimate whether a model fits. Look at how much VRAM your graphics card has. Subtract 1 to 2 gigabytes because your operating system and your display are already using some. Whatever is left is your budget. If you have 8 gigabytes of VRAM, your budget is around 6 or 7. That comfortably fits a 7B or 8B model at Q4. If you have 16, you can reach a 14B model easily and squeeze a small 32B if you have 24. A 32B model runs well. If you have no dedicated graphics card at all, you can still run a 3B model on your CPU, slowly but genuinely. And if a model is slightly too large, it still loads. That is the trap. The software simply puts part of the model in VRAM and leaves the rest in your system RAM, splitting the work between your GPU and your CPU. This is called offloading, and it feels like a small compromise but performs like a cliff. A model generating 35 words per second fully on the GPU can collapse to 2 words per second the moment part of it spills over. This leads to the most counterintuitive truth in local AI. A smaller model that fits entirely in your memory will almost always beat a larger, smarter model that does not. Your computer does not care how intelligent the model sounds. It cares whether the file fits. The difference between a good experience and an unusable one is rarely about intelligence, and almost always about whether every parameter has somewhere fast to live. If that is the first time anyone has explained that to you plainly, that is what this channel does. Subscribing costs you nothing and keeps the next one coming. Now consider what actually happens when you press Enter. That process is called inference, running the model, not training it, not changing it, just using the frozen dials to produce output. The model does not think in words, it thinks in tokens. A token is a chunk of text, usually about 3/4 of a word. Common words are single tokens. Longer or unusual words split into several. Roughly speaking, 100 tokens is about 75 words of English. Here is the part that explains everything about speed. To produce one single token, the model reads every parameter in the file, all 8 billion of them. Then it does it again for the next token, and again. That is why memory speed matters more than raw processing power. Your hardware is not struggling to be clever. It is struggling to move a 5 gigabyte file through itself, dozens of times per second. You will see this measured in tokens per second. Anything above 7 or 8 feels comfortable to read. Anything above 20 feels instant. Below 3 feels like waiting. Which brings us to the last piece of vocabulary, and the one that confuses people most. The context window. The context window is the model's working memory. It is the total amount of text the model can hold in mind at once, measured in tokens, and it includes everything. Your question, its answer, every earlier message in the conversation, any document you paste in. An 8K context window holds about 6,000 words. A 32K window holds about 24,000. A 128K window holds a short novel. But context is not free. While the model runs, it stores information about every token it has already seen, and that storage sits in memory alongside the model itself. Push your context window high enough, and you can add several gigabytes on top of the model file, which can quietly push you off that cliff from a minute ago. So when you set up a model and it runs beautifully, then crashes the moment you paste in a long document, you now know exactly why. Does any of this require a computer science degree to actually do? No, and this is the part that surprises people most. There are two tools that handle all of it for you. The first is Ollama. You install it, open a terminal, and type a single command. Ollama run llama 3. It downloads the model, picks a sensible quantization, loads it into memory, and starts a conversation. That is the whole process. The second is LLM Studio, which does the same thing without a terminal. It gives you a search box connected to Hugging Face, which is the enormous public library where nearly every open model lives. You search for a model, and LM Studio shows you every quantized version with its file size, then tells you plainly whether each one will fit in your machine's memory. Both tools use the GGUF file format, which came directly out of that llama.cpp project from 2023. When you see a file ending in GGUF, that is a model package to run on ordinary hardware. So what is this actually for? It is for the conversations you would rather not send anywhere. Medical questions, legal documents, a journal, client contracts covered by confidentiality, proprietary source code your employer will not allow near a cloud service. It is for reliability. A model on your drive does not go down, does not get deprecated, does not change its behavior overnight because a company updated something. It is for cost. After the download, every token is free forever. And it is for something harder to name. There is a particular feeling the first time you pull your Ethernet cable out, watch the network icon go dead, and keep talking to something intelligent anyway. You do not need a research lab. You need a machine you already own, a few gigabytes of free space, and about 10 minutes. Start with a 7B or 8B model at Q4. Watch your tokens per second, then climb. So you know what a local model is now. What you do not know yet is whether your machine will actually run one. That is the next video. Your VRAM, your RAM, the exact number that decides whether a model flies or crawls, and the one mistake that quietly turns a fast model into a slow one. Subscribe, and it will find you when it is ready. Right now, the artificial intelligence you use lives somewhere far away from you. By tonight, it does not have to.